So I'm Nico, this is Michael, this is Martin. So we're going to be designing an FPGA cryptocurrency miner. Our main motivation for this is that the biggest problem with cryptocurrency mining is the amount of power that it consumes. The amount of power that we use right now just to mine cryptocurrencies can power over 6 million homes in the US. That's a lot. So what we're trying to do is we're trying to go away from GPUs and ASICs because they consume a lot of power and some of them can be really inflexible. We're going to implement them on FPGAs to allow better power handling and implementation.
Yeah, so like Nico was just mentioning, we're going to try to compete with ASICs, which are application-specific integrated circuits. And so these are very, very costly types of devices, types of circuits to use for these cryptocurrency mining rigs. So, what is a mining rig? Well, it's a computational device that does a lot of math, a lot of shifting registers, a lot of comparing things, and at the end of the day, it spits out a hash function after a lot of computation, and it, whether or not this is a good output, the network of cryptocurrency accepts it or rejects it. The point is there's a lot of computational power that goes on during these hashing functions, is what they're called, and they're almost always fixed. So this is kind of where FPGA comes in that ASICs are very, very costly to develop. They can be upwards of like $500,000 to develop an ASIC. And GPU, the top-of-the-line GPUs are really, they hog a lot of power. So FPGAs are very nice in that they're robust. They can be modular, flexible, so you can program them and they will run with pretty good efficiency. So, the goal with this project is going to be to implement a hashing function onto an FPGA, and then once we've done that, try to map it to a currency, so a currency like Bitcoin that uses this algorithm. Something interesting to note about these algorithms is that there's one or two or three main algorithms that are used by a huge amount of cryptocurrencies. And so, in summary, I guess, as these cryptocurrencies are getting huge, which is what they are, hashing becomes more and more important, and it becomes more and more important to do it efficiently. So with Senior Design 2, that's what we're going to do. We're going to take our high-level design and put it on FPGA and do all the Verilog and VHDL and get it going. So, any questions?
So do you have an algorithm? I don't understand what's the point of your project. Do you have an algorithm? Something new, something, or
yeah, so
do you have a new idea how to do that?
Yeah, that's a great question. So the idea with our project is that FPGA cryptocurrency mining has been done before. Our project will make it modular in the sense that we can change cryptocurrencies quickly, we can add more cryptocurrencies to a given block, and so in that way, let's say a cryptocurrency does something where they call it forking, which is where they change the hashing algorithm. So in that time, a new ASIC has to be developed, and that takes a lot of time. So this is kind of where FPGA comes in that if our device is designed correctly and modularly enough to where we just have to change just a very small amount of thing in our code, implement it, we can pick up on some market latency where ASICs are lagging. Yes,
have you been able to simulate any of your modules so far?
And that's a great question. So for Senior Design 1, we got the overall high-level diagram done, and over the next 20 or so days, we're going to be doing exactly that.
The simulation? Okay,
yeah.
So you haven't got the simulation yet, okay.
So, I think I heard you say that you believe that you can achieve better power efficiency in an FPGA over an ASIC. I get it over a GPU, because that's a general purpose device. But what is it that leads you to believe that you can get better efficiencies on an FPGA than you can on an ASIC?
So that's a great question, because if I had said that, then that was incorrect. ASICs are absolutely the most efficient, and they can outperform when they're able to perform. They can outperform FPGAs and GPUs.
But you're programmable, so when they change the algorithms, you
exactly.
Got it.
Exactly. So I guess if you're defining efficiency as being able to operate, then yes.
Okay.
Could be more efficient.
Cool.
Do you have a defined algorithm, and does it require a floating point?
I'm sorry?
Okay, number one, where are you going to get your algorithm? And number two, does it require a floating point?
So to answer your first question, there's a defined standard where they have a bunch of hashing algorithms. The most popular one for almost every cryptocurrency, not every cryptocurrency, but hundreds of cryptocurrencies, is SHA 256, so Secure Hashing Algorithm 256. It's defined in our FIPS standards. So it's an official set standard of how this hashing is done. And so what cryptocurrencies will do is they'll take these defined algorithms that are release documents from our government, and they will implement them in various ways. So Bitcoin, for example, uses three different three different instances of SHA 256. And so that's kind of why we're stressing the modularity, so that if we can get this SHA 256 down, then we can go ahead and implement on Bitcoin or another cryptocurrency if we so choose. To answer your second question, Martin.
Can you repeat it?
Are you gonna need floating point?
It's all fixed point.
It's all fixed?
Yeah.
That's good.
Strictly by hand.
Anything else? Thank the team.